Records. No, I didn't mean this one. Records. Not this one again. Records. Go away. I'm here to talk about records in Java, which is a concise way to create a new type to store your immutable data. But what you see on the screen right now is just the syntax. What about its semantics? What do you mean by the term record? What are its features and limitations? What are the places that you should be using records and what are the places where you should not be using them? In this video, I'll try to answer all these questions using 5 examples for busy developers like you. Get ready to be surprised when I show you how to use records with pattern matching and sealed classes. In the first example, let's talk about how you can use records to model your domain values, which are also referred to as value objects. Before moving forward, let's quickly understand what a value object is. Imagine you are creating a solution for students, and one of the requirements is to be able to view a set of colors. They call it palette of 2 colors, and they often use it to select colors for their projects at their college. These colors, these palettes, are available as printed sheets, and they identify these palettes using different names like summer, winter, gold, pastel. In this case, palette of 2 colors is a value object, a concept from the business for which you are trying to create a solution for. And once the papers are printed, the colors cannot change. So we can safely assume that the data is immutable. Now, all the colors have a hex code printed on the reverse so that the students can use the code to create the same color in their online tools. And they also talk with their teammates to figure out if they are using the same color. Let's encapsulate this concept using a record, say palette to colors, with 3 components: name, color 1, and color 2. As you can see, a record is an expressive way to declare that it encapsulates the state of palette to colors using 3 components: name, color 1, and color 2. The intent of the record can be expressed using just one line of code that captures its components. You can convert this record to a regular class using context actions in IntelliJ IDEA and see for yourself the implicit methods that are generated by the compiler for you. The compiler creates the constructor, the getter methods, not the setters, because the fields are final. And you also get default implementation of equals, hash code, and the toString method. This is a comparison of record on the left and a regular class on the right. And as visible, you can see that a record greatly reduces the cognitive load for you to understand what the record does, what values does it stores. And even though the definition looks quite concise, you can use all the methods which are implicitly generated by the compiler for you. Are you wondering whether there is a real benefit to defining a record? Because you can use an IDE like IntelliJ IDEA to generate all those methods, or you can use another library like the Lombok. You have to understand that there is a difference between what you plan to do and what you actually do. Even though you have the IDEs, you have the libraries to generate all these methods for you, not all the developers do that. Do you know that if you do not override the equals and hash code method for your class, the collection classes like the array list might not be able to compare the values in a way that you desire? Let me show that to you. Let's navigate to the test class for this record and see if we create 2 identical instances but by using different variable names and add just 1 to an array list and try to compare if the list contains the other object. Will it return true or not? So yes, it says the test has passed. Let's go back to our record, convert this to a class, delete the equals and hash code method from this class. And if we go back to the test class, let's see what is the result of the test now. If I run the test class now, the assertion fails. Imagine you need to modify the default implementation of the constructor that was generated for your record. Is that possible? Yes, it is. Let's go to our record and insert a constructor. So unlike the regular classes, a record could have multiple types of constructor. Let's start with compact constructor. In this case, you don't see the list of the method parameters that are passed to the constructor because they are in the same order as specified by the declaration of a record. So let's modify the implementation of the constructor by adding code that checks for non-null values for all the components of this record. You can also add alternate ways to create a record, like this. But as a rule, this constructor must call this as the first line of code. This looks messy, but a better alternate is in works via this JDK enhancement proposal, that is JEP. Records are a good choice for defining data transfer objects as well. As the name suggests, data transfer objects are used to transfer data across applications or over the network. And having one call to transfer the data is better than having multiple calls to transfer individual data items. With records, you can define expressive data models with ease. Imagine an application where you work with data downloaded as CSV or comma separated value files like this, which stores monetary transactions for multiple banks. This is an example which shows different kind of transactions like NEFT transfer, creation of a fixed deposit, swiping card at a store, which is point of sale, and ATM cash withdrawal. Let's try to make more sense of these comma separated values by using a table. If you look closely, you will notice that the transaction details are made up of multiple data items separated using a backslash. Also, it is not the same across all kinds of transaction. I have seen and written code that extracts the description from the CSV files and stores it as a string in a database or another place. Be honest, have you done that too? It might seem a good solution in the beginning, but what happens if you have to query the data which is stored as string? It gets difficult to query data which is stored as string later in your application. What about the data which was not in the correct format or an invalid value? Wouldn't it be better if the data from files such as the CSV files or the JSON files are validated before they enter your application? First of all, let's model this data using records. Let's start by creating a record, bank transaction, that represents one line of comma separated values. Now let's implement trans details as a sealed interface. And let it be implemented by other transaction types we identified, like point of sale, NEFT transaction, ATM cash withdrawal, and fixed deposit. Let me declare all these records as public. And usually I find it easier to read a record if its components are placed on separate lines. Now, let me apply that to all the records defined in this interface. When you store your data using the correct Java data types, you can decipher incorrect or invalid values and define rules on how to handle it before your wider code base can access those values. It's very safe for all your application. In one of my previous applications, I was working with data downloaded from the same bank, which changed the format of their date randomly from this to this to this. I was able to intercept the changing format and create the right local date instances to record and store the right values. Once you have stored your data in a nested record like this, how would you use its components? To deconstruct a record, you can use record patterns, which was introduced in Java 19. I already have a detailed blog post on how you can use record patterns with IntelliJ IDEA. I have included the link to that blog post in the description. I don't want to cover that in detail because then I would be taking another tangent and not really talking about how to use records for busy developers. This is an example of how you might deconstruct the data stored in your records. This is a switch statement, and the case labels are the 4 record types which implemented the trans details interface which was sealed. So that's again a great benefit, because now I do not need the default case label, because the compiler knows that the trans details interface has exactly 4 records that implements it. In this way, I don't have to think about or code for the states which don't exist or which are not possible, but which we had to code when we used if then else statements. So this offers a powerful way to deconstruct the records and use its component. So to sum the first 2 points, the records can be used to model your data in a much easier way, and the record patterns, they help you to deconstruct that record so that you can extract the data and use it the way you like it. In this example, I talked about data stored as comma separated values. The same data could be stored as a JSON file like this or like this. In this case, the transaction details are again stored as another JSON object. It is up to you to decide as a developer how much control do you want on the data that you are accepting. How do you want to process the data which is stored? For example, this could be another record because I'm talking about date which has the components day, month, and year. And again, the beneficiary name could be a combination of a first name and last name. Similarly, if I'm talking about any kind of amounts, monetary accounts, I could be talking about the currency type and then the amount. Modeling data is not easy, and what you need from your application would be a guiding force to help you understand how you want to model your data. In the next example, I want to talk about how you can use local records to refactor your code. Imagine you want to refactor this code, separating the concerns. The first 3 lines are assigning a value or calculating a value, and the last line is printing the value to the console. Let's extract the first 3 lines to another method. Now, there are too many output variables to extract this method. So, IntelliJ IDEA would create a local record, and you can rename the record name if you want here. I just want to go with the default value. The default name of the local record is result, and I'm okay with it. The second change which I'm offered is if I want to change the name of the local variable. I think I'm good with that as well. This is the final extraction of the method. I get to modify the name of the extracted method as well. I'm okay with the default value. The first 3 lines of code have been extracted to another method. My initial purpose of separating the concerns has been achieved. In the next example, I want to talk about the frameworks or libraries with which you cannot use records. You cannot use records with frameworks like Hibernate to create your JPA entities because there is a mismatch between the JPA specifications and the implicit nature of records. The JPA specifications mandate that an entity class must not be final. It should have a no argument or default constructor, and it should define at least one component. All of these are not what record confirms to. Records are implicitly final classes. They do not have a no argument constructor because there's no sense of having a no argument constructor for a class whose components are final. Also, you can define a record which doesn't has any component. Now, what about the other frameworks or libraries? To answer that question, you have to ask what is it that the library or framework demands from your record class, and is there is a match with what records are offering. If you are talking about a library or framework that wants to use reflection to change the values of records, then probably your records will not work with those frameworks or libraries. Let me show you an example of using reflection with record components. Will it work? We'll find out. Now this is an example of a simple record, my point as record, which has 2 components, both of type int, x position and y position. Now let me go to another class which is trying to use reflection to change the int value, which is a final field for the record. Now this is the method which is being called, and let's see what's happening in the method. I have created an instance of a record here, and I'm just printing the values. Now I get access to the field by using the instance which I created here. And then I'm making the field accessible. Here's the new value that I want to assign to this field, and I try to set int using the new value. Will it work or will it throw an exception? As expected, you can see that this code throws an illegal access exception. So this explains why you might not be able to use records with some frameworks or libraries which try to modify the state of your records, because that's not what it's meant to be. Records are meant to represent immutable data. They would be a very good fit when you are working with your multi-threaded code. In the last example, I want to talk about how you can use records to elegantly model the data structures in your code and process them using record patterns. This is an example of seal interface 2-dimensional, which is implemented by 4 records here. The method process defines a concise and powerful way to process all the record types. The case labels have record pattern, and they also process the values recursively. You can also see recursion icon in the gutter area. In this video, I covered records beyond their syntax. I talked about semantics and shared 5 examples on how you can use them. 2 heads are better than 1. When used with other modern Java features like seal classes and pattern matching, you can create powerful, expressive, and useful data models using records. Let me know what other topics would you like me to cover in my next video. And thanks for watching.